So let's write the two functions that we need. First is going to check for win, and the second one is going to check for the draw. I'm going to put that here, call it func check for win condition. And this obviously will take some parameters and return a boolean if it was a win or no. I'm just putting a function now, and let's say return true to get rid of the errors. And func check for draw. And again, this is going to take some parameters and return a boolean in case if it was draw. And let's return true as well. So I'm going to check for draw first. We're going to do this function. And the reason we're doing it is it's super straightforward, and we can implement this fast. So to understand how this is working, remember we have an array of 9 objects. Some of them are nil, some of them are move inside, okay? So what we want to do is understand when our array is full of moves. So there are no more nils inside, which means there are no more available spaces on our board that the user can click. So if we remove all the nil objects from our array, and the count of objects in our array will be 9, it will mean that our array is full of moves and there is no other move left. So here we need to pass our moves, which is an array of move and optional, and then it returns a boolean. So let's return, and we want to access our moves. And we want to map this, so we say compact map, and we want to go through every single object of our array. And this will remove the nil object. If it was nil, it will be removed, and I'm going to say count is equals to 9. So we are removing this. If we remove all the nil object, which is compact mapping does, you can write command click on it, jump to definition, and see what this does. Returns the element of the sequence stored using the given predicate as comparison between the elements. So basically in our case, if it's a nil, it won't be evaluated, so it will be taken out from our array. So once we take out all the things and the count is 9, then this will be true and it will mean that it's draw. Otherwise the count will not equal to 9, so this will be false, and that will mean that our array, our game is not draw, and we can continue playing. Now for the check for win condition, this is a bit more complicated because we need to understand which positions are win positions. So for example, if any of the users occupies the first 3, first row here, it's a win position, or the second row or the third row, or we have then vertically 3, and under the angle this 3. So we have 1, 2, 3, 4, 5, 6, 7, 8 options to win. Otherwise, all the other options, combinations are not win positions. So we need to record all these numbers, in our case the indexes, which are the win positions, and then we can compare our currently available positions with our win patterns in the game. So to do that, I'm going to create a private var. Actually, we need a let here. We're not going to change this. And the reason I'm setting this private because we don't want this to be changed anyway in our accessed from outside of our class here. And the let means that this won't be changed. So we say win pattern. And this is going to be a set of sets, which is an integer in each set. So the set will contain small set of 3 integers, the patterns. So we need to say that this is equals to, and let's initialize one, and you will see what I mean here. So we have this, let's say the big set of, the big set is this one, which contains set of integers. And the set of integers will be the winning positions. So let's again go through this. I'm going to open. So we have 0 based array 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0, 1, 2 position is a winning position. Yes. So let's say 0, 1, 2. Then we have another winning position. So this is one set of numbers. Then the other one will be, let's create another set. So it will be 3, 4, 5. So let's put that here. 3, 4, 5. All right. Another set of numbers is going to be 6, 7, 8. So let's put that as well. 6, 7, 8. Okay. And then we can start like 0, 3, 6. Okay, second will be 1, 4, 7. And we're doing the verticals. 1, 4, 7. And then we need another one here. And let's see which one is this. It's gonna be our 2, 5, 8. Okay, and now we need to this under angle 1 and 2. So it's 0, 4, 8. So let's put that as well. Here we need a comma. 0, 4, 8. And the last one is 2, 4, 6. Right, so this is a set of array objects, numbers in our case, in a bigger set. So we have this. Okay, and once we record our moves, we will be able to compare with this set easily in order to see if any of the set contains the numbers. The order of the numbers doesn't matter if we have 2, 1, 0 or 0, 2, 1 in our moves. It will just, as long as the numbers are contained in this array, all these numbers are present, the order doesn't matter. So it means we have a win position. Okay, so we have our win patterns, and let's do it in our next lecture and complete this check for win condition function.